So the first part is understanding the quadratic formula. And this is a very personal preference. I say it's so much easier than completing the square. I prefer this method. I'm thinking that's where you're going to lead to at the end of all this, but we'll find out. So just a reminder, a quadratic has to be in the form ax squared plus bx plus c. They have to go in that order. And the quadratic formula is as follows. So it's x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. And notice that divided by is across that whole thing. Okay. So up until last year, you always had to memorize this. This year, for some reason, they decide to give this to you on the reference sheet. My guess is that most of you will have this in your head by the time the day is done today. But if you look at the reference sheet, the last page in the book, of course, so far we've talked about the cube factorization that will always be given. The very first one in there is the quadratic formula that's given. Okay, so as of today, we have covered 2 things on the formula sheet for the whole course so far. Obviously, we still have a ways to go. But this formula, like I said, is given. I'll stick it on the board as well, so it'll be up here for all tests and quizzes. Now, you did do this in Algebra 1. This was part of the Algebra 1 exam. You did it in geometry. If you had Mrs. Bauer, she loves singing the song that goes to this. So if you had her, you probably know this pretty well. Oh, she loves singing the song. She sang. She did. She loves this song. I don't know if the other math teachers sang. I'm not going to sing for you, but you are welcome to Google it or on YouTube and find a nice song, but she loves that song. All right, so first things we have to understand is that the part under the radical is called the discriminant. Okay, so we're going to kind of break this down. We're not actually solving anything yet. The part under the radical is called the discriminant. So if I look what's under the radical, that discriminant is b squared minus 4ac. That is the part under the radical. Okay. So a typical multiple choice question will ask you to explain the roots. Describe what the solutions are. So there's 3 scenarios that can happen. Your discriminant, your number under the radical, so that's all this is the number under the radical, could be a positive number. So you could get the square root of 18. You could get the square root of 2. You could get the square root of 10,000. It doesn't matter. It's a positive number. If that happens, you have to know to look for 2 solutions. Let's talk about why there's 2. What should be in front of all my radicals? Plus minus. So there's 2 solutions. They are unequal because you get a positive root 8 and a negative root 8, or a positive root 2 and a negative root 2. And they are real numbers. They're not pretty numbers, but they're real numbers. So you need to know that there's 2, they're unequal, and that they're real. So one option is you get this positive number under the root. Second option is you get a number less than 0, so you get a negative number under the root. So if I get a negative 18, my answers are no longer real, they're now complex. What's another word for complex? Imaginary. They're either imaginary or complex. They're going to say one of those 2 words. You still have 2 of them, plus and minus, the answer, and they're still unequal. Positive root negative 18 is different from negative root 18. So there's still 2, they're still unequal. This time, hopefully it's obvious that they're complex versus real. Okay. The last scenario, either you get a positive number, you get a negative number, or you plain out just get 0. Okay, if you just get 0, there is no longer 2 answers. You literally got 0. You got nothing under there. So there is 1 solution. This is the only time there's 1. Okay, the square root of 0 is a real number, so you're looking for 1 solution that's real. So you kind of, unfortunately, have to memorize this idea. This is not given to you. I think a lot of it you can talk through. Obviously, if I'm getting a negative under there, I know I'm looking for complex. I'm looking at my choices. I'm looking for complex. If I got a positive, I'm looking for real. They're both going to be 2 unless it's just flat out equal to 0. Then I'm looking for the one that says 1 real solution. All right, so this first part says describe the roots. So when you see the word describe, you are just using the discriminant. And the discriminant is just the part under the radical, not the radical itself. It's the part under the radical. So I'm going to start with b squared minus 4ac. Okay, just the part under the radical. So now I got to identify the a, the b, and the c. So looking at this first value, what is my a value? What's our coefficient here? 1. Excellent. What's our b value? -5. And our c value? Perfect. And we're just going to carefully plug those in with parentheses. So I'm going to get -5 squared minus 4 times 1 times -2. And then there's a lot of calculator work today. You're just going to go straight to the calculator. You're going to type it in exactly how you wrote it with parentheses in the proper spot. Okay. So again, with the parentheses, -5 squared is 4 times 1 times -2. Does 33 sound right? Okay, so now you have to, based off that number, describe the roots. So you're kind of doing some self-talk here. You're saying this number is under the radical. So let's eliminate a word. Is it real or imaginary if I get 33 under a radical? Is it a positive or a negative? Positive, therefore it's a real number. Okay. It's going to sit under the radical plus or minus. That tells me there are 2 solutions. And positive root 33 is different from negative root 33, therefore they are unequal. So I'm getting 2 real unequal solutions. I don't know what they are, but I have to be able to describe them. Okay. And we'll try the next one. So I'm just describing. So I'm going back to the discriminant. B squared minus 4ac. And I'm just identifying the a, the b, the c, and then carefully plugging them in. Who is our b value here? -1, good. Minus 4. Our a value is 2, and our c value is 2. And then again, you're just carefully typing in. Does -15 sound right? No? Yes? Yes? Okay, so now I'm saying this is the number that's under the square root. What type of answer is it going to get me, real or imaginary? Imaginary, so again, hopefully that's obvious. Imaginary / complex, however they word it. Okay, clearly I'm getting plus and minus, so there is 2, and they are not the same number. One's a positive, one's a negative, so they are unequal. So again, just a little bit of self-talk. Again, you have to kind of memorize this idea. Let's get the last one, b squared minus 4ac. Carefully plug in your a, b, and c in parentheses. So 4 squared minus 4 times 1. What do we get on for that one? Gabe, what'd you get? 0. Okay, so 0, if I put the square root of 0, clearly 0 is a real number. It's a number I've seen my whole life, so I know it's real versus imaginary. The square root of 0 is actually nothing though, right? So I don't have 2 answers this time because there is nothing there. I get 1 solution. So that's all you need to know, is that it's real and that there's 1 solution. Okay. So again, this first part is just typically what you'd find in the multiple choice. The second part is actually solving. So maybe the biggest question is, how do I know when to use the quadratic formula? And if you highlight this, simplest radical form, the moment they say that, it doesn't factor. Okay? So I'm not wasting my time factoring. The moment it says simplest radical or simplest a plus bi, simplest form means it's not going to factor. You got to go straight to either completing the square quadratic formula. So let's just start with quadratic formula. It has to be equal to 0 to begin, which it does. So it's x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and again, you'll say it enough times, it'll be ingrained in your memory. Obviously, it's given to you, so there's no stress about the formula. Based off this, Casey, what is my a value? To keep going, what's my b value? -1, yep. And my c value? +1. -1, +1. Okay, and then we're just carefully plugging in. Don't lose the x equals. That's part of the equation. So it's x equals. -1 is actually going to make that a positive. And now again, parentheses with everything. -1 squared minus 4 times 2 times 1. The 2a I typically just do in my head. That's easy enough. 2 times my a value. 2 times 2 is just 4. Okay. Now again, most important part. You are never typing the radical in. Just type in the junk under the radical, the discriminant. So use your calculator. You're only typing the discriminant in, the stuff under the radical, not the radical itself. So just like you did in the previous 3 questions, just type in the discriminant exactly with parentheses. Oops, I just screwed that up. -1 squared minus 4 times 2 times 1. I'm getting, does -7 sound right? All right, so -7 all over 4. All right. So now I'm going to pause there, and I want you to go to the top, and we're going to put the 2 next most important things down. Okay, first, you have to simplify the radical. Okay, these cannot go in alternating steps. You have to simplify the root first. Okay, second, again, they have to go in this order. This is a waste of time if you can't figure out the bottom half. Second, you can then divide out any common terms. You can divide out any common terms, but these are not interchangeable. You have to do them in this order, the order of operations. You have to simplify the root first, then you can divide out any common terms. Okay, so let's go back to our example here. All right, I have to simplify this root. So maybe I can't break root 7 down, but what has to come out of this problem? What does a negative become? I. So this becomes 1 plus or minus I. Obviously, 7's not going to clean up. All over 4. Okay, so I have to simplify the root. Now my next step would be, does everybody outside have something in common? If it does, I do that dead last. Dead last, I can clean that up. Does everybody outside have something in common? Not in this case, so this is just my final answer. I'm going to tell you right now, every single one on your exam is going to have something to clean up, but it has to be the very last step. You have to simplify the root, then you can clean up at the end. All right? So these don't actually get more complicated. They're pretty straightforward. We'll talk more about cleaning up the root when we get to one of those. So let's just take a look at example 2. The only thing in quadratic formula is that it has to be set equal to 0, which it is. So now we're ready to use it. So keep saying it to yourself. X equals -b plus or minus the square root b squared minus 4ac all over 2a. All right, Braden, who is my a value? Perfect. My b value. And my c value. Perfect. Carefully plug them in. Again, the 2a I typically do in my head. Ryan, what'd you get under the root? Sounds good to me. Are we good with 425? Okay, so here's the steps. You have to first break down the radical. There's no dividing, no cleaning up until you attack the radical first. So I'm going to get rid of that 425, and I'm looking for a perfect square and a non-perfect square. Perfect. 25 and 17. Love it. 25 and 17. Okay. Then we can say we know the 25 becomes a 5. So again, this breaks down everything we've been doing so far. Okay. So you have to attack the root first. Now you can say, look at all my outside terms. Do they have something in common? Can I take somebody out of all of them? 5 is perfect. So this becomes a 3 plus or minus root 17 all over negative 2. Okay. But again, I just want to stress that order is not interchangeable. It has to be root, then simplify. And I've got one last comment about this. If this is short answer, I love it. Don't do anything else. It's multiple choice. The Regents does not leave it this way. It's going to split at the plus and minus, and it's going to divide each of these by negative 2. So all your test questions are going to look like this. So it's probably going to say 3 over negative 2 plus or minus root 17 over negative 2. It's going to divide each of them by negative 2. It's just splitting at the plus minus. Again, do you have to do that on short answer? Absolutely not. But all the multiple choice will look like that. Okay. All right, let's try another one. Again, there's really nothing too fancy at this point. What's that? So we just left it as 1. Like, we could write out the 3 plus root 17 over negative 2, 3 minus root 17 over negative 2. Typically, they're going to leave it like this. All right, go ahead and try 3. Start with your quadratic formula and plug everybody in. All right, see, a lot of good work. We should be getting 44 under here. Okay. I'm going to kill 44, though. What two numbers can I replace it with? 4 and 11. And then the 4 becomes a 2. So I have 2 plus or minus 2 root 11 over 4. Okay, so simplify the radical first. Now the last step is, if everybody outside has something divisible, we're going to go do it. So I'm going to get x equals 1 plus or minus 1 root 11 all over 2. Technically don't need this 1 here, but I do need it here. Okay, so 1 plus or minus 1 root 11 over 2. And again, if this was multiple choice, they're going to write it as 1/2 plus or minus root 11 over 2. They mean the same thing. They're just dividing each term by 11. They might even go one step further and write out both the plus and the minus. I doubt it. Usually they'll leave it like this. All right, we'll do the same thing. Get the next one. Go get number 4. 12, I think, sounds perfect. Okay, so again, just using the calculator, get a 12. All right, then we're going to clean up that root. What can we replace 12 with? 4 and 3. And then the 4 becomes a 2. So 8 plus or minus 2 root 3 over 2. Okay, my dead last step, okay, is to look at all the outside terms and see if they have something in common, which they do. So I can divide everybody by a 2. So I should be getting 4 plus or minus root 3. Now I could put over 1. Do I need to say that? No. So I just 4 plus or minus root 3. So again, they always come in those conjugate pairs. That's 4 plus root 3 and 4 minus root 3. Same thing every time. Questions on this one? All right, keep going. Go get 5. Do you have it? All right, so some of you are leaving this answer a little goofy. This is a really important one to slow down with. What did we get under the square root? 1. Now, is that a number we should know? You should know the square root of 1, right? So we're not leaving that. I should get negative 5 plus or minus, what's the square root of 1? 1, all over 6. Now notice, we're not getting a root in our answer. That means this was factorable. Let's make a note. This would have factored real nicely. Okay, so that means I've got to state my two answers. I actually have to write these down now. So I'm going to get x equals, one option is negative 5 plus 1 over 6. And the other option is x equals negative 5 minus 1 over 6. Okay, so all that means, if the square root completely disappears, that just means this was factorable to begin with, and you got to go get your two very specific x values. So x equals negative 5 plus 1 is negative 4 over 6, which can reduce to negative 2/3. And here we're going to get x equals negative 5 minus 1 is negative 6 over 6, which reduces to negative 1. So my two solutions should be 1 and negative 2/3, which I'll kind of just stick in the bracket. Okay, so again, if the radical disappears, there's nothing wrong with that. It just means it was factorable to begin with, and then I got to make sure I write what those solutions are. Okay. So the last way they can obviously make these questions uglier, and they do, is they don't have it perfectly set up. It's not set equal to 0, so clearly you got to do what on the left side? Distribute. So let's go ahead and do that. So y minus y squared equals 1 minus 6y squared. Okay. And again, if I was going to factor, I would want my y squared to be positive. If I'm just using quadratic formula, I could care less because it just goes in the numbers. But I'm going to keep with the idea that I like my y squared positive, so I'm going to bring them over to this side. I'm going to add my 6y squared and subtract my 1. So my 0 is on this side. Now again, it truly does not matter because we're just throwing these numbers in the formula. So I'm going to end up with a positive 5y squared plus a y minus a 1 equals 0. And then I'll give you a minute to go quadratic formula. What are we getting in that root? 21? Okay, I think that sounds great. 21. All I'm thinking is 7 and 3. I don't think I can break 21 down. So this answer, and the only other thing I just noticed walking around, notice there's no x's in this equation, so technically it needs to say y equals. I'm getting negative 1 plus or minus root 21 all over 10. Again, 21 just doesn't simplify. That happened in Algebra 1. It's always going to simplify in Algebra 2. Okay, you're going to have to break it down. This just must be one I stole from the Algebra 1 exam. So again, anticipate, break down the radical, then divide out any terms. Okay. All right, flip to the homework page. So let's see, we're going to start with at the top section. So the top is just determine the solutions. Okay, so again, that's going back to the discriminant. No. We're going to go 1, 3, and 7 on just that top section. Okay, now, I just want to be super clear. I know this is just day 1, but the directions are never going to say use the quadratic formula. Like, you have to know when to use it. If it says simplest radical form, simplest a plus bi, that's your cue to use quadratic formula. It is just never going to tell you to use it. Obviously, it does today, but we'll never do that again. So we're going to go 11, 21, 25 on the front. So 11, 21, 25. And then on the back, let's go 45, 53. And we gotta do one more. Which one? A lot of these. That's a lot of squaring. I don't feel like doing. How about 41? That doesn't look like much work. All right, so remember, to use quadratic, it has to be set equal to 0. So you've got 10 minutes. My guess is you can crush most of these in 10 minutes. Absolutely.